Hi, back again for some geometry work, high school geometry Common Core. This is preparation for the New York State Regents exam. And what we're looking at is kind of the potentials for a 4-point question. What we tend to see is a need to either prove, do a synthetic proof with congruent triangles and some variation of that. We might see a coordinate geometry proof or an analytic geometry proof where you put some things on a graph, use slopes and all that. There's other ones too that come in there. It's been a while since we've proven theorems, so I just wanted to go over that again. We just finished the one on the angles of a triangle add to 180. I've seen this one before where we prove vertical angles are congruent, so I just want to take you through that process. How could we do it? What we'll start with, what they'll probably give you in this case is two lines. Perhaps AB is one line and CD is the other, and they intersect at point E. Okay, and they'll just leave it like this: prove vertical angles are congruent. Well, what I'm going to do then is I'm going to prove that those two angles are congruent, but without using the theorem. Okay, vertical angles are congruent is a theorem, but we're going to have to work on developing a proof to actually show that, to demonstrate that, to convince somebody that there's no other way that it could be. Okay, so there's a few ways to do this. What I'm going to do is I'm going to use the concept of linear pairs, and I've got a couple of those linear pair ideas out there. Basically, if you have a straight angle, this one right here, and we had a ray going through that straight angle, these two angles form what's called a linear pair. Right? A linear pair is when we kind of make two angles out of a straight angle. And of course, linear pairs will be supplementary or add to 180, right? Because they'll add to 180 because they make a straight line or a straight angle. So let's get started with this. How are we going to actually go ahead and prove? Okay, so what we're going to have to prove is that angle. And you know what? This time, last time I numbered the angles for you. This time we are gonna go ahead and use a three-letter path, and I'll show you how that works. It's good to review that. So I'm going to call this angle A, E, C. Basically, you're following that path. You're going from A to E, and then you're going off to C to create that space or that angle. And so that's how the three-letter path, you'll hear me say that, three-letter path works. Okay, so we're going to prove that angle AEC is congruent to angle BED. And that's your vertical angles theorem. That's what we want to prove. So what we're going to do is we're going to start out. What we're going to say is we see this intersection, right? And what we have is angle AEC and angle AED are, now I'm going to make a little bit of a skip, but I'm going to explain it. I'm going to call them supplementary first, and then I'm going to say because linear pairs are supplementary. So I'll kind of explain some of that, what I just shared with the person grading my paper, okay? Let's see, I've really explained a lot right there. I know what supplementary is, and I've related it to the idea that this is a linear pair, okay? Now the next move I'm going to make is I'm demonstrating my knowledge some more. The measure of angle AEC plus the measure of angle AED is 180. Okay, and that's because supplementary angles have measures that add to 180. Now, I'll explain that. The little m in front means measure of. So it's the measure of angle AEC and the measure of angle AED. Really, we should speak of their measures add to 180, not the angles themselves. Angles are a geometry figure. Their measures are what could be adding to 180 degrees. Okay, so I'm kind of going to hold off on that for a minute. Now I'm going to say kind of the same thing. Okay, angle AED and angle DEB are also supplementary. Again, we're repeating this process. I probably could have lumped those together, but I didn't see that at the time, so you just go with it. All right, if I would have planned it out better, I probably could have lumped those two together, those two steps, 1 and 3. Same thing with this. I could have put together steps 2 and 4. All right, so now I'm going to go with a measure of AED and plus the measure of angle DEB is 180 also. And that's again because supplementary angles have measures that add to 180. So it kind of seems weird for a minute that I'm doing all this, but you'll see what happens really soon. Okay? Now I'm going to do some little algebra here. You can handle it however you would like. All right. So the algebra I'm going to work on is I'm just going to subtract the measure of AED from both sides of this equation. So the measure of angle AEC will equal 180 minus the measure of angle AED. And I am going to lump these together. So I'm going to take 2 and 4, and I'm going to put them in the same kind of setup. So that angle DEB also equals 180, but look at that. It's minus the same exact angle. And that's by subtraction. Property of equality is what we have called it in the past, or I subtracted the same amount from both sides. You know, you can say whatever you need to say here to express what you did. You basically moved the measure of angle AED to the other side by subtraction. Now, well, these two right here are completely identical. When that happens, of course, those have to be equal. So the measure of angle AEC equals the measure of angle DEB, and that's, you could call it substitution if you want. Transitive property I've seen before. I'm going to use substitution. It's a little safer. And 7 angle AEC congruent to angle DEB. It's probably not necessary to do this. If they're equal in measure, they're congruent. Okay, angles equal in measure are congruent. Again, that's probably not a necessary step, but I just wanted to show that, and that's what we set out to prove. Okay, there it is. So that's it. Okay. Again, let's make sure you subscribe, like the video, and good luck to you on your geometry.